Morning, Preethi.
So let's get started. Yesterday we were talking about cloning, push, pull, and conflicts on remote and pull with rebase. These are all the things we have done, right? Let's look into a few more things today. Okay, let me go to the GitHub. Okay, this is the repository we are working on. So here, there is one important aspect, like we are making changes on our local and pushing here. That's how we push the changes, right? We may push different branches here. Let me go to some other repository we have. Here I have multiple branches. So here also I have only one branch. Sorry. So like I just want to have another branch. Let me just create another branch like B1. Maybe we could have pushed from local as well. See, create branch from master's options that I just created, just assuming 2 branches. So let's assume from local, we are making some changes and pushing the changes here. And in reality, like master branch will be restricted from accepting any pushes. You cannot directly push something to master, right? That's not allowed. This is what is allowed. Suppose anyone want to make changes, they'll create a branch from master locally or here, whatever it is, make changes here. And once this branch is working fine, then it will be merged to master. Also, you cannot merge directly to master. How do you merge? Let's say from local, we have developed this B1. And now I want to push this B1 or merge this to master. I can't do this directly. I have to push it as a separate branch as B1 only. Now I want to merge B1 onto master. So here you have something called pull request or else merge request. If it is Bitbucket, they are called merge request. It's GitHub, it's pull request. Whatever it is, it's the concept is same. So if you go to pull request, create a new pull request. You can create something from B1 to master. Of course, they are all same. Let me do one thing. Let me add something in B1. Let's say I'll just make some changes in this file. Okay, so yeah, now I want to merge this. So like we can raise a PR, new pull request from B1 to master branch. See here, this is how it will be shown and create a pull request. Whenever you create a pull request, you may define like what this is about. Something like this and create the pull request. So once you create the pull request, you can see requires pull approval from specific US for merging. Actually, the idea of this pull request is at the backend, who should merge this pull request will be configured, like who are all the people who should be merging it. So though it will go for review for them and they should review and accept the pull request, right? So only reviewers can accept the pull request, like leads or managers may be having that access, so that they'll review your changes before they merge it to master. Master branch would be a dedicated, a stable branch which will go for prod. So it wouldn't be interrupted. It will be, any commits will be allowed only to push. See here, require approval and also number of reviewers you can set either 2 or 3, it depends. So, and then they'll merge this. Of course, because I have all the access, I can do it. That's how changes goes in. It's successfully merged and closed. So later on, if you want, you can delete that temporary branch as it is successfully merged to master. See, you got those lines onto the master. That's how changes goes to master. So master branch will be dedicated stable branch for prod and only changes will be accepted through the merge request. But here I am allowed, right? Like I am doing it, but yes, there'll be restrictions on the branches. Like if you go to the settings, branches, of course, again, this settings access will be there only for the repository admin, right? They can only do that. So add branch rule set, branch name master, it cannot accept. Like if you see, rules, restrict creations, restrict deletions, restrict updates, all of that. Prevent merge comments from being pushed to reference. Like create authentication code. Right? Rules that does not target any resources and will not be applied. Like if you see here, same changes. Done. So now if you come to master, okay. So if you try to make some commits on this master, let's say I'm making again some change. Okay. Hello. Commit directly to the master should not be allowed. I think restriction is not imposed. Once again, branches. Oh, it's not saved. 1 minute. Master rules restrict creations. Allow only users the bypass permission to create matching references. Allow users bypass permission. This one require pull request before merging. Bypass can be there. So number of approvals, 2 people means it should get approval from 2 before it's merged. Require review from code owners or whoever made the code. So you can choose like how you want it to be. I'm just choosing simple uh, mm, branch rule set. Oh, that's a rule set name. So let's say PR rule set. Okay, rule set is created. Now if you go here and try to make some changes. Create a new branch for this. See, this is one option. Create a new branch and start a pull request or commit. Is it allowing for me or is it for all? Actually, we should see the...
No, I think you are in the master itself.
No, settings are for like it's a repo level settings.
Yeah, but you are editing the master file one.
Hmm. It should not allow.
No, from other branch, if you commit from other branch to, I mean, if you create
I
a peer
suppose it
from branch to master, then this rule will apply. If you are doing edition in the master itself,
require all commits to made to a non-target submitted via pull request before they can be merged. This one I have chosen, right? Even this will not allow direct commits as well. Oh, I think I did not select this. 1 second. Require code scanning, require status text to pass, require signed commits, commits push to matching references, commits requires it should not allow direct commits also. And then what is the point if it is only accepting PRs from other branches, but still commits are allowed? What is the what is the purpose of this? Maybe there should be another option at least. Require approval of most recent reviewable push. Approval of the most recent. When most recent reviewable push means by approver. Person who push require conversation resolution before merging. Request pull request review.
I
It
think second option is actually feasible. Requires review from the code owners. In that required pull request from merging, there is a second option. Required review from the code owners.
This means like if you are raising a PR, when you are choosing the reviewers, it should be code owners only. Like whoever made the code, they should be the reviewers. If you want this is the option. I just added this restrict updates. Let me I think under branches, this is what we did. Commit should be disabled actually. How it's
Kriti, you created the role. I think you have to associate the role in the master actually. Only we
associated.
created, right? Yeah, we have to associate with someone's.
No, we don't allow merge commits. Just a second. Here itself on the general settings, we have the options. I'm going into the branch rule sets for this 1 minute. Here we have when merging pull requests, you can allow merge requests. Add all commits from the head branch base of the branch. Allow rebase. Allow auto merge. These are not added. Add all commits from the head branch. This is for PRs.
What is that enforcement status disabled? Is it
You
active?
want to, if you want to
Rules will
view
be enforced. So I think you have to choose
and
active.
maybe. But this is not how it was. I think some changes. Restrict updates, restrict creations, requires a pull request before merging, requires two approvers, require approval of the most recent review push, require conversation. Okay. This should be fine. Does not target any resources and will not be applied. Targets, okay. Include all, okay. Include the default branch. Applies to 0 targets. Targets are not added.
Yeah.
Added target also, maybe let's see. But this is not how it was. But anyway. Till commit is there. You cannot commit to master because it's a protected branch. This is what I'm trying to do. Put a restriction, make a protected branch. So commit will not be allowed. Create a new branch from this commit and start a pull request. This is the way another way you can start pull request. You can create a branch from here itself and start a pull request rather than directly committing. See, create a pull request. Or else, like I have shown you, that also you can do at least 2 reviews. Because I don't have anyone added, it's showing like this. It's blocked because there were no reviewers. So we can add the users, collaborators, make them as reviewers. This is how it goes. There might be changes in the settings like this. Like earlier, it was not this case, choosing a target branches. But that's okay. That's we can explore and choose those. Whatever it is, the whole point is like master branch will be restricted from all the direct commits or direct merges. It's not allow. It will not allow. Like if you want to merge B1 to master, it will not allow. You have to raise a PR. Go here, create a PR, or else, like I have shown you, you can create a PR. After the reviewers and approvals, it will be merged to master. So again, starting from the beginning, let's say there's a repository. Imagine, assume, let's say it's a development repository, development code. The developers will make a change. We will create a pipeline such a way that whenever they make a change, it will trigger the CI/CD pipeline for every branch. So first, let's say there's a developer, they want to try some new feature functionality. They'll create a branch from some other parent branch and make their changes. CI/CD will be triggered, it will be successful. And once it is successful, developers may merge it to different branches. Like there could be different branches like dev branch, release branch for test environments, and then it could be something like master branch, and there might be so many feature branches, feature names. So different developers might be creating different branches as such. So CI/CDs will be created for them, and once it is successful, it will be merged to the respective branches. Generally, feature branches will be triggering a pipeline, and once it is successful, it will be merged here. Once merge means commit, again CI/CD. Suppose this is successful, that will be merged to release, and again it will trigger the CI/CD. So it will trigger the CI/CD, and that will be merged to other branches, and that's how it works.
Actually, normally when we create a actually pull request, right, is it if it is restricted from being committed to the master, do we need to create a kind of a feature branch, merge, like commit those changes there and then send it for a PR review and then like from the feature branch it will merge to a master branch? Is it something kind of?
You have to create the changes in some branch, test it, create a CI/CD for it, test it. If it is successful, then you will merge it to master. How to merge it to master is the where you raise a PR.
Okay. I mean, even for raising the PR, we have to create a like a separate branch, or if there is no branch, we have to create a separate branch, then merge our changes in that, or commit our changes in that, and then send it for PR review to the review like reviewers, right? And then they can review it and merge it to the master branch, right?
You have to create a separate branch always, right? From where you are merging into master. Merge is always from one branch to another.
Yeah, yeah. Okay, yeah.
PR or merge is always from one branch to another. So obviously with your changes, you have to create a branch. But how do you create is what I have shown you differently. Two ways, like you can just go here, create a branch from here, from master and raise a PR here itself, or else go to PRs and create a PR. Whatever ways you create from one branch to another, it is always, particularly to master, yes. Like you need approval, so we raise a PR to master.
Okay, okay. Yeah.
So
And
once
can you show the like set of implications that you applied or set of rule sets that you apply on the PR, Preeti, like the one which you
apply the
selected?
rule set on the branch, not on a PR. Okay, on the branches, we apply the rule set so that branch will not accept direct commits. It will accept only through PRs. Changes will
Yeah,
be accepted only through pull request.
yeah, yeah. I mean, can you show that once again? What all restrictions we applied on the branch? Like,
I'll show. Just give me a minute, I'll show you. So changes are done to the feature branch, it triggers the CI/CD. Let's say if it is successful, these changes will be merged to dev branch, let's say, and this will create again a CI/CD. Let's say if it is successful, they would merge it to release. If release is successful, like it will means whenever any changes are merged, CI/CD. Once it is successful, this will be merged to master. That's how changes progress from one level to another. This is where PR comes in. And this would be deployed to dev environments, this one to test environments, and this may be to prod, the master one. Again, this will trigger the CI/CD. This is the flow. Anyone, any questions on this PR part?
Preethi, what will be the difference between the future and dev? I think most probably we have dev environment only most of the places, right, Preethi?
Feature is where you are developing your code, checking for syntax errors, building, compiling, making sure its code is free from all these errors. Then you create another branch like dev branch. Of course, here also for feature also we are doing CI/CD, right? And then to dev environment. It could be, it depends on the projects. That could be a separate dev environment, or feature would be deployed onto the same dev environment. It could be either ways.
Okay.
Maybe in some projects, This may not be available. You don't need a separate one. This itself goes to dev, right?
Yeah, correct.
Everything goes to dev, or else that this is just for your local testing. Maybe I'll test this in my laptop, my local build MV and compile. But let's say then I would like to put it onto the actual dev environment. That could be the case.
Yeah,
Local
correct.
environment in the sense local, again, local remote desktop, not our personal laptops, like remote desktops. And then dev
Yeah.
it will be. So the whole point is how many branches will be there, how many environments they are doing. It all depends on changes from project to project, but this is an overview. Like this is how it goes from each level.
Yeah, correct. Yeah, there might be future branch also there. If there is a major changes, right? Enhancements or new development,
Correct.
that will be created as a separate future branch. And
Correct.
then they will release as a separate major releases.
Right.
Correct. Thank you.
Uh, So someone asking me to show this again, right? So branch settings, branches, repository rules set. Here is the rule sets. We have created these rule sets. This test 2 is working because it's targeting a branch. You need to add the target branches and then the activate it.
Yeah, what all the options we selected there? Like,
Selected the target branch, restrict. Actually, we don't need to select all of the restrict updates. You should select deletion so that no one will delete it. And then
okay.
require a pull request before merging. And here again, whatever options require approval of the most recent reviewable changes or conversation or pull review from Copilot kind of. Require code scanning. Some branches would need scanning, scan tools, a lot of things. And
Okay.
you have to create a rule set. Once it shows you, you will see this. Targeted
Okay.
branches.
Preeti, is it possible to create users and then log in as a user and check all these things and raise a pull request and see whether the pull request is coming to the
You can
main
create.
admin?
You can do that. You should have multiple accounts here, and yeah, you can do that.
Okay.
You can try doing it. Create multiple users and add those people who can approve.
Okay. Done.
Here in the collaborators under access, you have add people. You can add people. It's a public repository. And if you want to add people, find the people. If you have someone, you can add it. There were different people like with this name. I don't know them, but that's how you can add it. So that is about the pull request. This is definitely very much used in reality. And this is one thing. And the another thing is like branch protections I have shown you. I think that's it. One another option is, see here you have fork. What is this fork? There might be some public repository, public repos overall. You can search in the org. I want to search across GitHub. Let's say I want to search across GitHub, all GitHub for some Docker projects. There, Docker is an open source. There were so many projects, open source projects available, right? So if you want to give any permissions, I mean, let's say, okay, you want to take some open source project and develop on top of it. So see here, you can see fork. If you fork it, the entire project will be added into your own account, right? This will be added into your own account. And once it is added, you can just work like your own repo. The advantage of this fork is if you fork it, if anyone made changes on the original one, it will be like you will be seeing those changes if anyone else have made any changes here. That's the importance of forking. Like I have forked some repositories. Means you take an open source project and you can develop on top of it. There are some projects like
Is this applicable even if you have private account, private GitLab account?
Yes, you can. This is about copying something from your open source or a publicly available repository. It's not about your repository. You are getting something which is available publicly. This is from MediaWiki, some PHP application. So where we have 4 credits. So it's added into here. You can see, you can make any changes. If you make any changes, it will not be visible to the original one. Whereas if original one is made any changes, you can see them.
Because
It's like
I was just worrying about if we just try to copy or try to fork these repositories, would there be any virus and that comes to our network? How uh, protective it is?
you are making changes and these are confined for you. It's not impacting the original one.
Okay.
This is not impacting the original one. It's added like your copy. This is your own copy. You are taking some open source project and developing on top of it. So how is it impacting the original one?
Now, what if the file contains any virus and if you open that and execute it?
That's what, it's an open source project. It's up to you. It's not mandatory. You should take this open
Right.
source
Okay.
project and
Mm.
work on it. No one will do it. Maybe let's say you want to contribute to some open source project, or else you want to develop your own on top of this open source. That's where you go for it. No one is liable or no one is responsible for your scans or vulnerabilities or virus kind of. It's up to you. Why should
Right.
we fork it? It's a your own
Mm.
risk.
Right.
I'm talking about, yes, there is an option. You can take
Option.
some public repos. If you want, you can contribute to those open source projects, or else you can develop on top of it. That's an option. It just copies into your account.
Okay. Thank you.
And whatever changes you make are not going to impact the original one. Whereas if any changes in the original one, you would see them so that you will know like what are happening with the changes. We will not use fork so much, like unless you want to contribute or you want to develop something. But yes, that's an option available. The reason for showing this is for our lab, we can fork some publicly available repositories for our hands-on kind of. That's the reason for showing you that. That's how you can utilize it.
Mm, Actually, where we get that option, like under codes, like for forking. Uh,
On the public repo, you will get the option. If you take any public repository, like Jenkins, Docker, here you will see the fork. Fork
okay,
your own copy.
okay.
That public repository, you should be seeing that option.
Okay.
Already number of forks, the ratings, how many are seeing it, all of that information you can see there.
And these what all options we are having in kind of a GitHub, right? Those would be same in GitLab also, or those are kind of a different. I mean, same concepts is applicable there.
Concepts would be similar. The UI, the names, the concept, the terminology may be different. Like example, this is called pull request. That's called merge request on Bitbucket. The UI may be different, options may be different, but with a little practice, you should be able to go ahead.
Okay.
So that is all about Git and GitHub. Till now, whatever we have learned is from the perspective of managing the files, right? We have learned, okay, how do we manage our files? How do we revert the changes? How do we rebase the changes? Or how do we push, pull, clone, conflicts, or how to resolve them? All of them we have learned, right? But now, how do we integrate in the CI/CD pipeline? How do we integrate this Git with Jenkins? Means, okay, like till now I'm talking about whenever there's a commit, pipeline should be triggered. How do you make that? Okay, whenever a commit is done, how can you trigger a pipeline? How do you integrate it? So all of those things are pending with respect to Git and GitHub. We will be learning it, right? So the Git concepts are completed from basics till all the concepts advanced, or the concepts whichever we need are covered. If you can master whatever we have covered till now, if you are thorough, I'm pretty sure you can work comfortably on Git. Make sure you are thorough with the concepts. You have clarity with the concepts. That is very important. You can work on the projects. You can clear any interview questions. This is more than enough. We have covered lot many things, which is more than enough. So Now we will be jumping into the next part of learning Jenkins, right? We have to learn Jenkins, the CI/CD tool, like how you would integrate, all of that comes in. So let's begin with Jenkins. Jenkins again works on multiple operating systems, but we would choose the Linux here. Why and all we'll discuss. So we'll get started with Linux basics. Good to go, or any questions? And by now you know the flow, right? All your Git hands-on assignments were here till all the day 5, right? Assignments, quizzes on every day you have. So this is how you should progress.
Preethi, I have one question about rebase. I was just practicing rebase yesterday, and I just followed the same method that you showed us yesterday. So I had only one doubt that it arranges the commit IDs in a linear. If you use rebase, Git
Mm.
rebase and master, it arranges all the commit IDs in a linear option or linear order.
Hmm.
And then I use uh, the merging command using git merge master. So it created a new commit ID. So the concept is we use rebase to achieve to order the commit IDs in a linear order without creating other commit ID. Is that correct?
Correct. It
Okay.
will not create a commit ID as a topmost one into the branch.
Can I quickly share the screen and take you through what I have done for my satisfaction?
Can we do it at the end, Kiran?
No problem.
Yeah, right. Remind me at the end. We can do that towards the end.
Cool. Yeah. Thank you.
So now let's get started with the operating system basics. Any questions and all, like you can ask me before we go to that part. This is what we did. We went to remote. This is done. Now let's go through some OS basics and then we'll get started with Jenkins. So let us go through some basics. So let's try to understand what is an operating system. Why do we need Linux for DevOps? What is meant by virtualization and virtual machines? Like what is cloud? How it is helpful for us? Let's have a look at operating system. I believe like every one of us know what an operating system is, right? It's nothing but a software which works like an interface between hardware components and the user, right? Like every update or else like suppose you need to do some task, you have bought some laptop, you want to do some painting or play some game, whatever you want to do, you need an operating system, right? So operating system works like a bridge between the user and the hardware, right? It works like a bridge. So with which you can open the application. So you will install an operating system so that you can launch any application. You can work with any component of it. So every computer must have at least one operating system to run other programs like MS Office, Notepad, all of these things. So that's what is an operating system. Not only that, it will take care of allocating the resources and adding multiple applications, working with the multiple applications by resource allocation and task management. All of that would be taken care by an operating system, isn't it? So, and also when we say, okay, it will help you to multitasking, it will help you in resource sharing, it will help all of these things. When we say that what actually is doing it, there is a component called kernel, right? That's a core component or the central component which does all this task. It makes the communication between the hardware and the software possible. It uses monolithic kernel which consumes more running space where Windows uses microkernel. See, whatever kernel is the core component. And again, depending on the type of the operating system, kernels are different. It's a monolithic kernel in Linux, which works very faster, which is more efficient, but which consumes more space. Whereas Windows uses microkernel, which consumes less space, but also it's less effective or efficiency than Linux. So kernel is the core component. And another difference is like in Linux, like if you look into Linux, it's more secure, it's and less vulnerable for thefts and attacks when compared with Windows. Also, Linux is open source, available for free, whereas for Windows license, right? Those are the very simple or basic differences. And there are lot many differences with respect to the usage. Like in Linux, the file names, these are all case sensitive, but in Windows, that's not the case, right? Linux, it uses monolithic kernel, Windows uses microkernel, efficiency, right? And if you want to work with multiple files at a time, CLI is always preferred and Linux is always preferred from security perspective as well. Windows, as it has got the GUI, it consumes more resources. Also, it's less faster when compared with the Linux operating systems. So those are the few differences we have. We'll see a lot of differences when we get into the Linux hands-on, but these are the simple or the basic differences. The forward/backward/ differences we'll see. And for DevOps, why do you need it? Majority of the tools like Docker, of course, now we have Docker for Windows also, but it's natively developed for Linux. Ansible, Ansible server should be Linux. Prometheus server should be Linux. They can monitor, or the Ansible can configure Windows servers also. Prometheus can monitor Windows machines as well, but they should be installed only on Linux machines. So that's how there is a dependency. And for all the before said reasons like the security, all of these concerns, we have Linux more widely used in real time, that too for DevOps. So that's the reason even we would do everything on Linux. Again, like we have shown, we discussed in the beginning, Git works on any operating system. So Git will work on Linux also. Concepts, commands are same. Only installation differs. Same is the case with other tools. So that's the reason we are going to learn Linux for our DevOps. So if anyone new here, we don't need to worry. It's just another environment operating system. Like we are using Windows, we'll use Linux. Working with the files and folders, navigating through the file system, all of that we will be focusing on. And then comes the concept of, okay, first, okay, we need Linux. How do we get any Linux system? Anyone? Let's say to learn DevOps, I need Linux. So how can we have a Linux operating system?
We can use AWS and launch EC2 instance using Linux.
That is on cloud. Like, let's say if you want to use Linux on your system, let's say mine is Mac or else mine is Windows laptop. How do I use Linux?
I can use virtual machine and set up Linux.
Right, that's where a virtual machines or virtualization concept comes in. Virtualization uses software to create an abstraction layer over computer hardware that allows hardware elements of a computer like processors, memory, storage to be divided. Like this is the architecture. Let's suppose this is my laptop. Let's say I have some Windows. This is the host operating system. Now I want Linux machine. So I can create some virtual machines like this. But to create virtual machines, we need something called hypervisor. What is a hypervisor? Anyone? What is a hypervisor?
Actually, hypervisor is kind of a set where you can monitor the virtual machines, like kind of a monitoring. We can do it provides a UI where you can monitor multiple VMs.
So hypervisor is like a software with which you can create a VMs, with which you can launch the VMs, right? So hypervisor is a software with which you can create and launch the VMs. And hypervisor, like some examples of hypervisors are like Oracle VirtualBox, VMware, VM Workstation, all these comes under hypervisors. So it's basically the component which will help you create a VM. And whenever you create a VM, you should allocate resources to a VM. Even this will help you allocate resources to the VMs, right? And let's suppose you are having 20 GB. And if you want to allocate a 5 GB here, 5 GB to this, all of that can be taken care by the hypervisor. And how many VMs you can run, it depends. I have 20, maybe I have to put something for the own host 5 GB. Maybe I can run 3 VMs. So it depends on the resources available, how many VMs you can run. Also, size of the VM depends on like which type of VM it is and all, right? So all of that depends on the depending on the resources of your host. But this is the architecture. Anyway, we are going to have a separate chapter for this, like where we will be learning this virtualization and its importance. But yeah, you'll be having a host operating system and then a hypervisor, and then yes, you can launch some Linux VMs and use it. This is called virtualization. And there is another architecture with this, like see here, this is the another type of architecture which is called bare metal. Means directly on the hardware, you'll be having a hypervisor on which you will launch some VMs, right? Whereas this is a hardware and you have some host operating system hypervisor. This is how it is. So this is the bare metal architecture. This is called bare metal architecture. This is used for our like a personal purpose, but in companies, like even companies, they'll have their own architecture. This is the architecture which is used a professional setup. Let's say they have a huge hardware. On this, they can have directly hypervisor. This is called bare metal hypervisor, something like ESXi, a best example of bare metal hypervisor, on which you can launch the VMs, right? Even companies, that's how they'll have their own data centers, right? By creating a VM. In both the cases, either it is for your personal purpose or the like official setup of your the data centers by the companies, there is a lot of overhead if you notice, right? You need to like, firstly, it's expensive. You need to have the hardware, like your laptop, if it is personal, or else they have to have this hardware, which is quite expensive. On top of it, virtual machines will be launched. To manage them, you need a separate team of people where you manage these virtual machines, right? Like, because see, let's say, okay, let's take a personal case. I will be using it 2 hours per day, but still I need to maintain it, right? I need to maintain the backup recovery. If something is done and it's not starting up, it's my responsibility. Same is the case here. You need to maintain backup recovery of those VMs. There should be a separate team who will manage all this for their maintenance, right? So during disasters, if it is crash, you should be responsible of recovery and all, right? Or else something has gone, it has crashed or shut down. Again, you need to be taking care of it. So lot of overhead on maintaining those VMs. Expensive, because if I need more VMs, I have to expand the hardware. Expensive, a separate team should be there for maintaining them. It's a lot of overhead in the process of backup, recovery, maintenance, right? It's a costly, obviously. So these are all the challenges you have in maintaining your own VMs on your laptop, or else companies managing their own data centers. So what we can do, instead of creating our own VMs and put an overhead on our laptop and we have to take care of their maintenance and all, why don't we use some instances on cloud? Similarly, companies also, rather than creating their own data centers, they were using infra from someone else's data center, which is nothing but a cloud provider. Am I correct? So what is cloud? On-demanding computing resources delivered to us over the internet is called cloud. It's a self-service and it is metered. So 1 second, just a second. So this is self-service and it is metered. Meter means you pay only for what you use. Let's say you are consuming them for 2 hours. You have to pay only for 2 hours. You don't need to work for their maintenance, recovery for the rest of the hours in the day, right? That's how it's metered. Self-service, you can just get from the console, right?
Yeah.
Sorry, some disturbance at the back. So on-demanding computing services delivered to us. We don't need a separate team. We can go to the console and get the infra whichever we need. And it is metered. You pay only for what you use. You don't have overhead of their maintenance, recovery, and all of them will be taken care by the cloud provider. It's nothing but we are using infra from someone else's data center. So who is that? That's nothing but cloud provider like AWS, GCP, Azure. They have their own data centers. They are maintaining their own data centers. We are using infra from their data centers. Are we good? Any questions? And there were so many cloud providers. These are some of the cloud providers here shown here, AWS, GCP, Azure, and so on. You can see the graph. This is from 21. You can get the latest graph. Whatever be it, clouds are evolving every day. New clouds are coming. So if you master and understand, have knowledge of using one cloud, that will help you. You don't need to learn all the clouds available. So even for our lab, rather than creating our own VMs, we'll be using some VMs from cloud, AWS for our lab, for our learning. That's how we get used to cloud environment. So we can go ahead, create a free account on AWS and create some VMs. Can we proceed? Any questions from anyone?
No, Preethi.
So, you go to your Drive, Google Drive, lab setup on AWS, like how to create an instance. How to instance here means a VM, okay, easy to instance. So how to create a free account, everything you have here. So you can follow. Of course, screenshots may be different because those UI changes, but it would be, there will be similarity. Okay, so now you can just get into the console. Okay, you first create a free account. I already have it, so it's showing me this. Create a free account. Free account is nothing but this account is available for free for 12 months, 1 year. But again, there are limits on what is free. 12 months free, but what is free? See here. There are different service on AWS. This is the EC2 service, which is like a VMs or instances. So this is 750 hours per month is free. Means there is some free tier limit. So 750 hours per month is free. If you go beyond this, like if you go beyond 750, like 850, 800, you have to pay for those extra hours. But 750 is more than enough. So what is the free tier limit for each service you have on this page? Accordingly, you can use it for 1 year. Every month you get it for 750 hours for free. So that's the free tier details for every service you have here. So you can go ahead and create a free account. If you go here, you will be asked to provide some email ID, account name, and verify it and proceed. It's just 5 to 6 steps. Like you create any Gmail or any other account, you can go through and create it. Even screenshots were there, but the UI might be different. See here, this is how it is some time back, but now it got changed. But almost it will give you an idea what all you have to provide. During this process of creating an account, it may ask you for your credit card or debit card details. You have to provide it. That is to validate the individual. when you add it, like 2 rupees or 1 rupee will be deducted and it will be credited back as well. But yeah, you have to provide those details. And once you are all done with this, you can log into your account. So you will be creating an email ID, which is nothing but a root user. That's how we log in. Enable multi-factor authentication is also mandatory. So you will be taken through those steps when you're creating an account or later on. So initially, actually, you should not be having any instances. So once you log in, search for EC2 and you should be going here. This is the service where you use it. Terminate means stop and delete them. If you don't want it, they'll be deleted. If you want to reuse it, select the instance and stop it. Anyhow, how are we getting those instances here? How to create an instance? I'll show you. Let me proceed. Here you have launch instance. Give some name to your instance, like demo instance and instance type, whether it's Ubuntu, Windows, Red Hat, you can create any type of your instance. We will be choosing here in the drop down Amazon Linux 2. Amazon Linux 2 is CentOS Red Hat based. CentOS Red Hat, these are different distributions in Linux. So choose something from there like CentOS or Red Hat based and type of the instance. And another thing is type is T2 micro means it provides you the resource size like 1 CPU and 1 gigs of memory should be enough and it is free tier eligible. And also it will ask you to create a key pair. For the first time, create a key pair. What is this key pair also you will understand. Just create a key pair. The concept behind it is SSH. We will learn it separately. So when you do it, a PEM file will be downloaded. It's a private key. You should save this securely because this is needed to connect to that instance. That's all you have to do and leave everything else as it is and launch the instance. I'm again showing you, give some name. Under the machine image type, choose Amazon Linux 2. Instance type, choose as a T2 micro and launch instance. That's how instance will be created. You can see the instance here. See, this is coming up. Okay, fine. Instance, EC2 instance means a virtual machine is created on AWS data center. How to connect to it and how to use it. There are multiple ways of connection. Before I go and show you how to connect to them, any questions from anyone? Okay. So, first simple way to connect is select it. You will see a connect option. Connect to instance. So here is the way you can connect, right? You can see the connection here. It's connected already. This is an Linux machine. We can run any Linux commands. This is browser-based quick connection, which you can use, but all the time it may not be available to connect this way. So how can you connect the other way? Select it again, click on connect. This time, this is how we connected now. Now go to SH connect. Right, you will see an example command. Copy this command. If it is Mac, launch your terminal. If it is Windows, launch your git bash. You can use git bash, right? And go to the location where you have this file downloaded. Copy this command here. Right, SH file, the PEM file, we downloaded some time back, right? And easy to user @ IP address. What is the concept of SSH? What is this PEM file and all we will learn separately. This is just to give you an idea of how you connect. You have to run this command from the location of that PEM file which we downloaded. It will ask for confirmation, give us. It says it's unprotected. If you are Linux person, you might be knowing it. It's about permissions. Again, we will learn it separately, but run this command when you see this error. chmod 400, you means you are restricting the permissions. Now again, run the sh command. You are connected. This is the way you have to use to connect your EC2 instance. This is more widely used method of connection. You can use terminal or git bash. If it is Windows, you can use git bash. And there is another like different SSH clients are there, like git bash. If in Windows, if you want to use putty, here is the document. If you want to connect via putty, putty is another SSH client. Like you have git bash, putty is another interface. If anyone interested, you can go through these steps. And also small video is there how to connect from. It's all like different interfaces. How do you connect? Don't get confused. If you can do this, that is enough. Any questions from anyone? I'm also writing here. If it is Mac, launch your terminal, run that SSH command. Okay. If it is Windows, launch git bash and again run the same SSH command. It should work. But if it is Windows, like git bash, you have different SSH clients like putty, mobexterm, like git bash, different interfaces, that's all. So if it is putty, steps are there, mobexterm also same steps. And git bash uses PEM file which you downloaded. Terminal also uses the PEM file which you downloaded during the creation of the instance. But putty and mobexterm, these uses another file type called PPK file. Putty private key. But how do you get that? We get a PEM file. From PEM file, you have to generate PPK file. How do you generate it? Using puttygen. Puttygen is another tool. So using puttygen, you have to convert PEM file to PPK because putty and mobexterm uses PPK file. How to generate it? How to download puttygen? Right? All those steps are available here. Putty, using putty, puttygen, a small video on that, everything here. This is additional and optional, so don't get confused. If you have good git bash in your Windows, you are all set to go. These two are enough. This box is additional part. If you are interested, you can do it. Am I clear?
Yes, Preethi.
So you can connect your instance. And from here our Linux journey begins. Linux basics of navigating through files and folders, all of that we'll see. And then we'll see installing packages. Then we'll install Jenkins on the server and we'll proceed. So this is for the next class, Linux basics, file permissions, SSH concept, all a few things we have to learn before we start our Jenkins. Any questions from anyone? We are having 10 people join today. I just want to know how many of you are into Linux? How many are new? Okay, raise the hand who are all new. You have raise hand option. You can raise and keep it raised so that I can count it. How many are new? Only people who are new. Raise the hands, only people who are new. 2 people. I see 2 hands raised. That's all. All other 8 people are into Linux.
We know basic commands, not
Yeah, just
very much,
Okay, basics are enough. Navigating through files and folders.
Yeah, that is we know.
Okay, only 2 are completely new. Rest of you have basic knowledge, I think. Okay, not bad. Okay, fine. So I think we can get started from here in the next class. If you have any questions, anything we can look at regarding it or anything you have. And this is the agenda for the next class. And next class will be on, like you all know, from Monday to Friday. So next class will be on Monday. So yes, any questions from anyone?
Yes, Preeti. I'll just share the screen.
Right, just give me a minute. And one more thing, whenever you create instance, don't just leave it running. If you want to reuse it, stop it and proceed with it. So that tomorrow you come and start it. If you don't want it anymore, you can terminate it. Terminate means it will be stopped and it will be deleted. But if you leave it running, it would be counted under those 750 hours. So stop it. So that is all from my end for today. If you have any questions, we can proceed. And Kiran, yes, you can share your screen.
I think I'm not able to share the screen, Preeti. Okay, yeah, I can now. Let me, okay, entire screen. So I was just practicing Git rebase, where if you see here, I've followed your step first. First, this is the logs of master branch, and this is the log of branch 1,
I could
where,
put the log, Kiran, it was perfect. So yes, this is the
yeah.
expected.
So this is the after rebase. There was no new commit ID, and it was merged from master to B1.
Yes,
Then,
it be
then I
added
want,
in
yeah,
those. Hmm.
yeah. So
Hmm.
then I want to understand. I was still not satisfied with my understanding, and then I did normal merging without rebase command. So,
Hmm.
but here you can see, as you can see here, the new commit ID is created if I don't use rebase command. So, but all these things are in linear order.
Hmm. Linear
So,
art because that's how changes might have happened.
correct.
Hmm.
So, so we use rebase to avoid this extra commit ID.
Correct.
Okay, yeah, right.
Extra commit ID also we're adding it as a topmost one. In
Right.
this branch, if you
Yeah.
someone sees this branch, they think, okay, this is the topmost one, but that's not the case, right? It's coming from other branch.
It's
So,
coming from the other branch. Yeah.
so that's why we do rebase.
Okay. Could you say that again, please?
Like we want to, we are getting changes from other branch, right? It's not generated in this branch. So we don't want it as a topmost one. So we do rebase.
Okay. Okay.
Yeah, it should be a parent. Parent first, child second, right?
Come again, Sachin?
It's a parent-child relationship, right?
Right. First parent comments, then the child comments. Yes.
Yeah. Okay.
Okay. That's it from my end, Preeti. That's it.
All right. Thank you all. Yes, you can get started with your hands-on. Get thorough on the Git concepts, complete all the quiz assignments, interview questions, everything related to Git on the portal, and get yourself thorough with it. Do the hands-on number of times and be prepared with the Git by Monday. That should be the agenda. Don't pile up the things. Just don't keep it for next weekend and so on, because by next week we'll be starting with Linux, Jenkins halfway will be done. So you should be able to spend some time on the new tools. So finish everything, whatever we have done in this week. If any pendings are there, create your AWS account, create your EC2 instance, right? And get all of these things set up, done and ready by Monday.
Yeah. Okay.
Have a
Thank you,
happy,
Preeti.
yeah, have a happy weekend. Enjoy your weekend. Also have a happy learning over the weekend. Spend some time for the learning. And thank you all. Good day. Bye,
Yeah.
everyone.
Thank you.
See
Happy
you on
weekend again. Yeah. Thank you.
Bye-bye.
Bye.
Thank
Thank you
you.
all.
Bye.
Bye.